Okay, Kelsey, I couldn't get the video to record the other day when we actually did this section, or yesterday, I think it was. So I'm recording it now and shipping it over to you. This is the second half of section 3.7. And so in this past section, we did like equations and we were trying to figure out slopes. So we just found the ordered pair, like these two guys, and we found the slope and identified that as the rate of change. Okay, so now we're doing the same thing again, but we're just dealing with a graph. Okay, so the graph of the temperature function during a particular day is given. The temperature X hours after midnight is f of x. What is the average rate of change between 4 a.m. and noon? So I'm going to start with, I'm going to put A over here, and I'm going to leave some room so we can put B over here. So A is 4 a.m. to noon, so we're going to go 4, and I'm just going to do a little a.m. so we know it's 4 a.m. And then noon is 12 p.m. technically, and we got to find those temperatures. So 4 a.m. is here, and it's at about 40 degrees, and 12 p.m. or noon is here at about this mark right here, which is 58 degrees. So we've got 40 and 58 degrees. 40 here and 58 degrees here. And then we just calculate the slope. So 58 minus 40 over 12 minus 4. And that is 18 over 8. And 18 divided by 8 is 2.25. And that is degrees per hour, actually, because these units up here on the top are degrees and these are hours on the bottom. So it is increasing at a rate of 2.25 degrees per hour. It's increasing because it's positive. If it was negative, we would be decreasing. Like in part B, we're going from 3 p.m. to 8 p.m. Okay. And let's see, 3 p.m. is going to be at 3 p.m. is 1500 hours, so right here, and we go all the way up to the top, and we're about at, let's see, this point right here, which is over at 68, and 8 p.m. is 2000, I guess, and that is at, I would say, 52 and a half. So we've got 68 and 52 and a half. All right, 68 degrees. 52.5 degrees. I'm going to need a calculator for this. So I'm going to walk and talk at the same time. So starting with our y2 and y1, we're going to have a negative number here. We'll get 52.5 minus 68 over 8 minus 3, which is, I don't know, something on the top, but 5 on the bottom. 52 and a half minus 68. Okay, so I just figured out that I was in here. 15.5 divided by 5 is 3.1. Negative 3.1 degrees per hour, okay? I think when we did this in class, we actually just got negative 3 because I think we rounded it off to 53 or something. Anyway, as long as you're close, that's fine, just because you are approximating it with a graph. So this is basically saying it's going down 3 degrees per hour, or 3.1 degrees per hour, which is kind of typical in a day. Afternoon, usually you see a decrease in temperature. Before noon, you see an increase in temperature typically, okay? So that's kind of how that works. And then this entire time, what we've been doing is when we were finding like 4 and 12, like we were trying to approximate the average rate of change, which in a sense is trying to find like the slope of this line where you're connecting them. And that line is called a secant line, where you're connecting those two things. So this is just an approximation. As you can see, like the graph itself does not go in a straight line, so it's not approximating every point on that line, but like where the increase is along each one of those points along that line, but it's just doing the average across the board from those two places, okay? So that is a secant line, all right? And again, secant line is just saying, you know, the average rate of change of the secant line is just saying the same thing as a slope. So we've got, you know, the y-coordinates subtract over the x-coordinates subtract, okay? Now, that all's pretty straightforward. Now we're going to get to something called the difference quotient, which is probably the hardest thing on the whole page. This example right here is probably not too bad, but then when we get down to this bottom example where we have x to the third power, it gets a little bit confusing. So here we go. All right, it's not too bad, but it's kind of hard to follow a little bit. So find a formula for the average speed. Okay, I'm going to talk about average speed for a second. Average speed is velocity, v of t, and we had an equation up above, like in one of the first examples, that was said that velocity of a falling object was negative 16t squared is how you identify a velocity. Okay, so this is the equation that we're going to use. Even though it doesn't say that, we're going to pull that from one of the first examples. Okay, find the formula for the average speed of a falling rock from a time of x to a time of x plus h. Okay, then we're going to we're going to do this part. Okay, so just like in the problems before, we would start with our 2 coordinate points. Okay, and we have like this going on, except instead of plugging numbers in, we're going to plug x and x plus h in. And then as soon as we do this, I'll tell you kind of like how the h comes into play. Okay, like what the h is. Okay, so we're going to use that negative 16t squared, and we're going to plug x in to start with. And if we plug x in for the t here, we just get negative 16x squared, and it's just like kind of changing the name of the variable. Versus if we plug x plus h in, it'll be like negative 16 times x plus h squared. We're plugging that x plus h in there instead, all right? And so what we need to do is we need to FOIL this guy right here. So we have x plus h times x plus h, and that is x squared plus xh plus another xh plus h squared. That's what he will look like. Or he is x squared plus 2xh's plus h squared. And that was kind of fast, so if you need to pause it, go for it. And then we have to multiply everything through by a negative 16, okay? So I'm going to distribute my negative 16 through, and he is negative 16x squared minus 32xh minus 16h squared, and that's what he will look like, okay? So kind of ugly stuff, but bear with me for now, okay? Now, just like we were doing before, we're going to do y2 minus y1 over x2 minus x1, and we are going to subtract them. So it's this guy minus this guy. So negative 16x squared minus 32xh minus 16h squared. That thing minus negative 16x squared all over x plus h, this guy right here, minus this guy. Okay, and some things are going to cancel out really nicely for us. Like on the bottom, I see x and minus x will cancel out. So on the bottom, all I have is an h. And then minus a negative over here is just going to change to a plus. So I have 16x squared and negative 16x squared. Those two are going to go away. And then I have negative 32xh minus 16h squared. And that's all that I have left over. But I have h on the bottom here, so I'm going to do this. I'm going to pull an h out of these two top pieces. So I've got h times negative 32x minus 16h, if I pull an h out, and then I can cross those two h's out. So this guy is all that I have left over. Oh, what a mess. Okay, this is something called the difference quotient. Okay, and the reason why he is really nice is that we can do the second part of this problem very easily from this if we already have it calculated, okay? So we want to go and we want to find the slope or the rate of change from 3 to 3.1 seconds, okay? So before, what we would have to do is we would have to go from 3 and figure out what that thing is by plugging in, and go 3.1 and figure out what that thing is, and then we would find the slope from there. But what I can do is, if I already have this formula, all we need to do is identify what x is and identify what h is, okay? So you remember when we plugged in x and x plus h instead of plugging the numbers in, right? We wrote it like that. Well, in this case, x is like my 3 here, right? That's where we're starting from. That's our starting number. And then x plus h is like 3.1, right? Well, if x is 3, then our h has to just be 0.1. I hope that makes sense. So like this is where my x is, my x plus h will be that guy. And then all I have to do is plug those two numbers in for these two guys. So negative 32 times 3 minus 16 times 0.1. 32 times 3 is 96, negative 96. And then 16 times 0.1 is negative 1.6. So we've got negative 97.6. and we are going in speed. This is in feet per second. So it's falling at an average rate of 96 feet or 97.6 feet per second. Okay. Now you might be saying that really didn't save us a whole lot of time because it would have been easier to plug the 3 in and plug the 3.1 in, solve these guys, and then find the slope. But if you're trying to do like a bunch of ABCDs, right? Just doing this equation once and plugging those numbers in, for ABCD would be a lot faster having this equation to start with rather than having to plug each one of them in a bunch of times, kind of like we did up here. When we're having ABCD and an ABCD, having that difference quotient equation to start with just makes it easy. I just plug in the X and the H and then we call it a day. Okay. So that makes it a little bit faster. All right. So down here, that difference quotient is like you plug in the X plus H, you plug in the X and you solve. The reason why they only have H down here on the bottom is that when you do like the X plus H minus the X, it just ends up being H. Okay. I don't usually follow this equation. I just go ahead and I look at X and X plus H, and then I figure out what these two guys are going to be in relationship to my function here. Okay. So they want us to find the difference quotient. That's like finding this stuff and plugging it into the slope formula, like y2 minus y1, x2 minus x1. Okay. Now this is really ugly because it's x to the third power. Okay. All right. So we'll get to that. So the first thing they want me to do is plug x in, and I just plug x into x. So that's not going to change it. It's just going to stay x to the third over 55. Okay. And then the next thing I do, they want me to plug x plus h in. So it's x plus h to the third power over 55. And now I have to take that to the third power, which is really, really, really gross. Now we've already taken him to the second power. And when we took him to the second power, it was x squared plus 2xh plus h squared. And then he's x plus h again. And then we have to like FOIL that all out. So that will be x to the third power plus x squared h. This is 2x squared h plus 2xh squared plus h squared x plus h to the third power. That's a lot of stuff. There's 1, 2, 3, 4, 5, 6 pieces. Okay. And then I can simplify some of that. Okay. X to the third, he won't simplify. So we're just going to leave him as x to the third. X squared h plus 2x squared h. That is 3x squared h. Okay. That's those two guys. Then we have xh squared and another xh squared. So that's another 3xh squared. I'm going to erase my thing over here. And I have plus h to the third power at the end, all over 55. Ooh, really yucky. I promise the ones on the homework assignment are not this bad because this is an x to the third power. Okay. All right. So now I subtract. I do my subtraction stuff. Okay. So it's this guy minus this guy. So I have x cubed plus 3x squared h, and my kids are being awful, but whatever, all over 55 minus x to the third over 55. Okay, that's that top part. Then we still have this guy minus this guy on the bottom. X plus h minus x. Okay. Now that x plus h minus x, this x and this x go away. So that's kind of like why in the formula they only have h on the bottom there. All right, so he's just going to be h on the bottom. And then we have a common denominator here when we're subtracting. We have to have a common denominator. So, but one thing I notice is that x to the third minus x to the third, those go away. And all I have left is this stuff on the top, really. Okay, so I've got 3x squared h plus 3xh squared plus h squared. No, h cubed. I think that's h cubed instead. Yep, he should be h cubed. All over 55. But then I have that over h on the bottom. Okay. All right, this is like super lots of information. So if you need to back up, go for it. It's kind of confusing, okay? I'm going to make this h over 1. And then I'm going to take it times 1 over h because I keep flip it to the top. Okay. And then what I can do is these 3 pieces up here all have an H in them, so I'm going to reduce them all by an H. So I'm going to take an H out. I'm going to take that H out. I'm going to take one of these guys out, so I'll still have one left over, and one of these left over, so I'll have, or one of those, so I'll have 2 left over still. And that will cancel with that H. Okay, if I take one from each of these 3 pieces, I will cancel that H. So now, when all is said and done, I just have 55 on the bottom, and all I have left on the top is 3x squared plus 3xh plus h squared. And this is my difference quotient. Oh, man. Okay, then they say use that to find the average rate of change from 8 to 8.01. Okay, from 8 to 8.01. So then I just have to identify what x is and what h is. And x is 8. And h is basically what the difference between these two is. And it's 0.01. So then I just plug those 2 guys in there. So 3 times 8 squared plus 3 times 8 times 0.01 plus 0.01 squared, all over 55. Okay, and oh my heavens, that's a lot of math to do. Okay, 8 squared is 64, and 3 times 64 is something. 3 times 64 is 192. Okay. 3 times 8 is 24, times 0.01 is 0.24, and then 0.01 squared is 0.0001, all over 55. And if I add all that stuff together, 0.24 plus 0.0001, and then divide by 55, it was like 192.24, something like that, all over 55. And my average rate of change is 3.5. Okay, 3.5 was my average rate of change. Whew, from 8 to 8.1 seconds. All right, that's a lot of stuff going on there. Okay, so I promise you that the ones on the homework assignment are not going to be that bad, because this one was just gross because of the x cubed. Okay, I think one of the ones on the homework assignment is just going to end up being x squared, which we already kind of did up here, which is still kind of ugly. But anyway, there's that. But hopefully that made sense. If you have questions, come see me Monday or whenever you come back, and we'll get it all figured out.